Hey everybody, in this next video lesson, we're going to talk about something known as polyatomic ions. Now, before we get to what a polyatomic ion is, let's review what an ion is. An ion is a particle with a charge, whether it be a positive charge or negative charge. So far, we've been working with just simple ions like sodium 1+, or chlorine 1-, or even calcium 2+, right? These have been all regular ions, just single atoms with a charge. On the other hand, a polyatomic ion, as the name would suggest, poly means many, atom ion. These are ions made of multiple atoms. These are typically groups of nonmetals acting as one singular ion. Usually they're negatively charged, but every once in a while you'll come across a positively charged polyatomic ion. Now, polyatomic ions are quite common. They're found in lots of different situations in the everyday world. One of them is as simple as OH. This has a negative charge. This is known as hydroxide, and this is found in lots of cleaning supplies. Another polyatomic ion found in cleaning supplies is ClO-1. This is known as hypochlorite. This is the main ingredient in bleach. So as you can see, a lot of these polyatomic ions are quite common and found all over in your everyday life. There are lots and lots of different polyatomic ions, some more common than others. But in our class, we are only going to use these 8 common polyatomic ions that you see on the screen. And I've organized them into a chart. Over here on the left, you're going to need to know the name and formula for the following polyatomic ions. Acetate, which is C2H3O2. Chlorate, which is ClO3, hydroxide, which I introduced to you on the last slide, OH, and nitrate, NO3. These are all 1- charge ions. Our 2- charge ions are carbonate, CO3, and sulfate, SO4. There's one 3- charge ion, PO4, and as I mentioned, most of them are negatively charged, but one rather common positively charged polyatomic ion is ammonium. And these are the 8 that you're going to need to know for our class. These are the ones that I'm going to use most often in our examples. Now, I have these 8 common polyatomic ions along with many of their friends listed on the back of our periodic table. So if you flip over your periodic table, you'll find common polyatomic ions. All of these 8 are bolded on the back of that periodic table in that polyatomic ion chart, but there are many others there as well. If you want to, and I strongly recommend, click on this link to the Quizlet and you can practice your names and formulas. On one side of the flashcard, there's the name, and on the other side, there's the formula. You'll have to click on this link through your notes template, but I will also post a copy of this link in the description of the video posted on YouTube. Now, the next logical step is that we are going to start naming and writing formulas of ionic substances that include these polyatomic ions, but that is for another video lesson, and that takes care of this one. Thanks for watching.